Here we have a sketch of the graph y equals sine theta. We've got theta in degrees along the x-axis, and then we've got the output from the function sine theta on the y-axis. The maximum value is 1 and the minimum value is -1. You can get any output values between there and including 1 and -1, but nothing greater. That's a really key point. The next thing we notice is that this graph is periodic. It has a period of 360 degrees. That means the graph repeats every 360 degrees. It has a period of 360 degrees. We've got this shape here, and then it repeats. Look, it's here, and then it repeats, and so on. It repeats every 360 degrees. That means we can write the following. Sine of theta plus 360 degrees is equal to sine of theta. Another thing we notice is that this graph has rotational symmetry of order 2 about the origin. Now what this means is that it's an odd function, and that we can write minus sine of theta is equal to the sine of minus theta. Two useful properties of this graph. Let's take a look at solving some equations using sine theta. So we'll choose a range. Let's go from 0 inclusive up to 360 degrees. And we'll say that sine theta equals √3 over 2. So we'll grab a calculator, make sure we're in degrees mode. So the inverse sine of √3 over 2 is 60 degrees. So one solution for this is theta equals 60 degrees. Let's look at where that is on the graph. There's 180, 0, so 90 is about there, so 60 just off that. Now this is a sketch, but I can still draw my line up to the function there and across here like this. In fact, I'll make it a bit longer. So this value here on the y-axis, this represents √3 over 2. But look, between 0 and 360, there's another value here of √3 over 2, and that is when it's this number of degrees. So we've got to find this. Now we can find this value from the symmetry of the graph. Notice here, 0 to 60 is 60 degrees, and because of the symmetry of the graph, from 180 to the value that we want is also 60 degrees. So to find a second solution within the range 0 to 360, I can do 180 minus my first solution. So this is 120 degrees. Let's check this on a calculator. So if I do sine of 60, I get √3 over 2. And if I do sine of 120, I get √3 over 2. So both solutions are correct. So there are two solutions in this range. There are more, but it's outside the range to 0 to 360. Let's have another one in the same range, but this time we'll do sine theta equals minus √3 over 2. We grab the calculator again. We're still in degrees mode, and we'll do the inverse sine of minus √3 over 2. And I get the answer of theta equals minus 60 degrees. Now minus 60 degrees straight away is outside the range 0 to 360. Now let's mark it on the graph. There's 90, so we say minus 60 is about there. I'm just going to write it above because I'm going to draw the line down to here, and then like I did last time, I draw a nice horizontal line across, and see it's these two solutions that I'm after in the range 0 to 360. So how do I find them? Well, look at this. It has a period of 360 degrees. So sine of theta plus 360 is equal to sine of theta. Well, I know one value, even though it's outside the range. So I can find a second one by doing this. Theta plus 360. And that gives me 300 degrees. So I know that that is one of the solutions. And I can also see from the symmetry of the graph that this here, 180 to this point, is the same as the minus 60 to 0 from the symmetry of the graph. So I can do 180 plus 60, or this is the better way to do it. It's still 180 minus my first answer, because 180 minus minus 60 is the same result as 180 plus 60. So that gives me 240 degrees. Let's just check that on the calculator. So we're doing sine of 300 equals minus root 3 over 2. And sine of 240 equals minus root 3 over 2. The key thing to remember to find other solutions for sine is to do 180 minus the first angle.